Good morning, this is your Stats Sensei, Mr. Spensei, and we have an assignment on the paired t-test. This specifically is going to be a confidence interval. Um, Scenarios, get the lead out. It's a long scenario, so let's read along. Lead, found in some paints, is a neurotoxin that can be especially harmful to the developing brain and nervous system of children. Children frequently put their hands in their mouth after touching painted surfaces, and this is the most common type of exposure to lead. In Flint, Michigan, many have alleged that the amount of lead exposure is significantly higher outside than inside, and have recommended that daycare centers no longer allow children to play outside due to the amount of exposure to lead. That's pretty extreme. They're saying, hey, you're more likely to have lead poisoning outside than you are inside. Don't let the kids play outside. The city of Flint has commissioned a study to explore this claim and randomly selected 9 children. Okay, so we have 9 from over 35,000. So we have a large population in the urban daycare centers to conduct a study. To conduct the study, the hands of children were wiped clean. They were then allowed to play outside for 1 hour, after which the amount of lead in micrograms on each child's dominant hand was recorded. The children's hands were cleaned again and they were permitted to play indoors for an hour. After 1 hour, the indoor playtime ended. The amount of lead on each dominant hand was measured again. The distribution of differences is normal for the amount of lead on each child's dominant hand, and the data is shown in the table below. So what we have is the amount of lead from outside and inside. We need to put the outside information in column L1 and inside information in column L2. And if I go to stat edit, you can see that I already have that data already input into L1 and L2. All right. What did they ask? And so I'm going to go ahead, since I know this is a paired, I'm going to go ahead and uh, calculate the differences. You do that by going blue button 1 minus blue button 2. And the reason I know this is a pair, just so you know, is they got tested twice. They got tested once inside and once tested outside. So the 9 children were tested twice. And anytime you're tested twice, it's paired. All right. So there's my differences. I recorded them here. Now, I could have gone 15 minus 16 and got -1, et cetera, and subtracted it by hand. But ultimately, I'm going to need that information anyway in the calculator. So I went ahead and put it in. All right. So it says create a 95% interval for the differences in lead toxin outside minus inside. Please always pay attention to the order. All right. Now, they thought that outside was going to be greater. All right, so outside minus inside is the order we're going in. So we expecting to have a positive number because the first number is supposed to be bigger. So our formula is just going to be the same as what we've had before when we were running a regular t-test. The only difference is we're talking about the differences. So we're talking about this row of data, specifically the data that I'm highlighting. We're looking at these differences right here. All right. All right. So um, if I go stat calc, one variable statistics, and I press blue button 3, I get my data list of L3, which is where my data is. And I find a sample mean of 3 and a sample standard deviation of 4.85. All right. Please don't forget N is the number of pairs. All right. We're not saying that we have 27 data points or 18 data points. We're saying we have 9 because we have 9 pairs of data because there are 9 children. Our degrees of freedom is based on the formula of n minus 1. All right, so to calculate T star, which we don't have, we now have the sample mean, we have the sample standard deviation. We don't have T star. To do that, we're gonna have to go second vars, inverse T, and we're doing a 95%. So parenthesis 1 minus 9.5, close parenthesis, divided by 2. Degrees of freedom in this case are 9 kids minus the 1. And we end up getting a T-star of 2.306. And this is the way you would show your work. This 9 minus 1 is obviously the degrees of freedom. All right, so we have 8 degrees of freedom in this case. We can go ahead and plug all of our information into our formula. We can plug in the sample mean of 3 for X bar. We can plug in our sample standard deviation right here. And of course, the number of pairs, which was 9. And this was our T-star. We're going to run a one sample paired T interval. All right. And when we draw this, please remember, hypothesis tests are centered on the mean, where the population mean, whereas confidence intervals are centered on the sample mean. So this will be centered on our sample mean of 3. All right. And we're looking for a 95% interval. So this area right here is 95%. Let's go ahead and run this thing. Stat test number 8, because we're looking for a T interval, just like we'd run a regular T test. We have data because we entered all this data into the calculator. The data list that we're interested in is an L3. So blue 3, that's the differences. And we want a 95% interval. All right, so I end up getting negative 0.7312 to 6.73. All right, so we're 95% confident that the true population mean of the difference in amount of lead outside minus inside lies within this interval, where this is my lower bound and this is my upper bound. If it had all been positive, because we went in the order of outside minus inside, if it had all been positive, that means this number would have been bigger than this number, and that would have mean that the outside was larger. But here, we can't say that because we have some negative values. So there, because 0 is contained, we can't say that there's a difference in the amount of lead found outside versus inside. All right. Might be close, but if 0 is contained, we can't say that we're 95% confident. We might be 85% confident, but we're not 95% confident. All right. I appreciate you watching and look forward to seeing you on the next one, which will be a continuation of this same problem, but will be a hypothesis test. Thank you.